Many of us were raised on the candle theory of the universe. It describes a cosmos that sparked to life with the Big Bang and is now slowly burning through its limited wax, heading toward a certain point where the light goes out and leaves only an endless dark. But that linear path to a dead end ignores the most basic rule of physics, the law of conservation of energy and matter. Energy cannot be created or destroyed, it only changes form. If the total sum of matter and energy in the cosmos remains constant, then the idea of a permanent heat-death end is difficult to reconcile with a system that has no way to actually delete its own contents. In this light, the fading of distant stars looks less like an ending and more like the gathering of raw material for a new phase. This logic leads to the cosmic cycle theorem, which replaces the straight line of time with an 8-stage circle. This model redefines the black hole. Rather than a cosmic grave, it becomes a necessary component in the universe's recycling process. Understanding this cycle requires us to follow a specific patch of debris from a previous universe through all 8 stages of the loop. Tracing this path reveals the black hole as the mandatory engine required to restart the cosmic clock. We begin at stage 1, the nebula. These massive clouds of plasma and dust are the leftover remains of the previous cycle, the raw cosmic soup from which everything else must be built. Over billions of years, gravity draws this debris together, forming stars that eventually cluster into the stage 2 structure, a dormant galaxy. While studying massive early galaxies like XM 1275, the James Webb Space Telescope identified a strange anomaly in how these systems behave. Doppler analysis showed that despite having trillions of stars, these dormant galaxies have zero rotation. They sit entirely stationary because they lack a central anchor to give them direction. A dormant galaxy is a machine with its engine running but no steering wheel. It possesses immense energy, but it requires a violent catalyst to begin functioning as a system. That catalyst is stage 3, central compression. Without any rotation to keep them in stable orbits, millions of stars and gas clouds drift directly into the center of the galaxy, resulting in massive high-heat collisions. This crushing density breaks the orbital momentum of the matter, collapsing it into stage 4, the birth of a primordial black hole. This newborn black hole acts as a cosmic conductor. Its extreme gravity provides the missing ingredient, angular momentum, organizing the stationary stars into a unified spin. This momentum creates stage 5, the active galaxy, pulling itself into structured spiral arms. The gravity of the central black hole provides the stabilization necessary for these life-harboring structures to form in the first place. But the cycle continues into stage 6, galactic consumption. The black hole's pull becomes so dominant that it begins shredding nearby stars in tidal disruption events to fuel its own growth. Eventually, the system reaches stage 7, the hypermassive black hole. At this point, the entire galaxy has been consumed and crushed into a single point of density. This raises a question of capacity. If you keep forcing matter into a single point, can that space eventually become full? The Pauli exclusion principle dictates matter cannot be compressed indefinitely. At the gravitational saturation threshold, quantum pressure pushes back against the inward crush of gravity. When breached, space-time rebels, triggering stage 8, the cosmic rebound, violently expelling matter back into the vacuum. This transformational event creates a brand new nebula, indicating that the universe operates through a continuous cycle of consumption and rebirth. We can see this cycle in our biology by looking at a single atom of iron within a human blood cell. The atoms that make up our bodies have existed for billions of years before the Earth ever formed. Those same atoms almost certainly survived the extreme compression of a hypermassive black hole during a previous iteration of the cosmos. Our existence is a physical manifestation of this recycling process, built from the remains of galaxies that died long ago. If matter is finite and constantly recycling, it forces us to wonder, how many times in past cosmic loops have these exact atoms combined to form this exact moment? Looking at a dying star or a dark patch of space is not a view of a final ending. the cosmos lacks a final full stop. The light doesn't permanently vanish, it simply takes a different form before beginning the cycle once again.